Hello, everyone. I'm very glad to welcome you all. My name is Vlad Bagnuk. I'm Community and Marketing Manager at Developer Shore. Follow us on social media to follow our jobs opportunities, activities, and future webinars. Also, a recording of this webinar will be available there. Links to our social media accounts you can easily find in your email. And now I give the floor to the speaker of our webinar, Joshua.
Hello, can you hear me?
Yeah, great.
Sure. Should we start?
Yes.
Got it. Got it. Okay. All right. I will share my screen and then let me know if you can see it. Can you guys see my screen? This one.
Yeah.
All right. So let's begin. So thank you again for this opportunity to share with you this topic, because for one thing, this is a very important topic. At the same time, this is going to be relevant for you and for your future opportunities as well. So that said, the title of my talk is Automated Machine Learning Engineering in the Cloud. And we will talk about the details and at the same time, the reasons why we need to have something like this in our machine learning journey. So to introduce myself, I am Joshua Arvin. People call me Arvs. I am the Chief Technology Officer of NuWorks Interactive Labs. At the same time, I am an AWS machine learning hero. And if you look at the right side of the screen, I'm also one of the subject matter experts who gets invited to update the certification exams taken by a lot of people globally. So if you probably took an AWS certification exam, maybe one of the questions I created could have been there. So yeah, pretty cool. And then I'm also the author of the book, Machine Learning with Amazon SageMaker Cookbook. So feel free to check this in Amazon. So if you're interested in doing some serious hands-on work when it comes to machine learning experiments and deployments in the cloud, in the AWS cloud, then this may be the book for you. So it's a 700 to 800 page book, and all the steps, as in step by step, you won't get lost and you'll get your ML experiments to work, including deep learning experiments, including NLP stuff, and so on. So enough about myself and enough about the book. Let's now go straight and proceed with the topic. So whenever we're talking about machine learning, it's important that we define what it is. So one of the simplest ways to describe what machine learning is if you want to perform an intelligent operation, something that a human would probably do is to, let's say here we have an example of an image of a cat, and we want to identify or classify it if it's a cat or not a cat. So if you are given an image as input, and then what would be the output? So your machine learning program or model, that's the correct way to call it, your machine learning model would process the image as input, and it would return a string or a number which would tell us if it's a cat or not a cat. So a cat, it can be represented with a 1, or not a cat, it can be represented with a 0. So if we put an image of a dog, then it should return not cat. So one of the reasons why companies and professionals make use of machine learning is that not everything can be hard coded. So that's one of the reasons why people make use of machine learning, because we make use of existing data and we generalize and build a model on top of existing data, so that if there's new data, we can use the previous data's representation to perform predictions or to perform that intelligent task. So again, that's one way to introduce what machine learning is. And again, it's about performing intelligent operations or decisions. So given that we have data, how would it be used to build models? So there's something called the machine learning process. So again, what we have here is a simplified view of the machine learning process. So if you have performed some machine learning experiments and deployments before, you're probably aware that this is supposedly circular. But for now, let's leave it linear. And what do we have here? What we have here is we start with data collection. So we start with maybe raw data. Your data could have been in databases. And then the next thing we do is we clean the data and prepare it for training. And at the same time, we perform data visualization. We try to look at patterns. And then we perform feature engineering where, let's say, we will try to create new columns so that maybe that column would best summarize a behavior, or maybe it would help improve the model's prediction power. So after the first four steps, we should have the data ready for model training. So what we will do there is, again, the best term to do it is to generalize over the data presented or the data used to train a model. And we also perform hyperparameter tuning. So what we do there is we try to tweak and select the best configuration possible so that we would have a good model. A good model would be able to perform a decision or a prediction, or an intelligent decision with a high enough score. So if the goal of your model is to perform a prediction and check if, let's say, the image is a cat or not a cat, it should make as much correct answers as possible whenever possible. So ideally, it should be better than a human if possible. So if it's given an image of a dog, if your model told you that it's a cat, then it's a mistake. So you want less of that and you want more correct answers. So that would fall under model evaluation. And then if you're happy with your final model, then you deploy it so that a lot of other resources and entities could connect to that endpoint and perform predictions using your deployed model. So how would an inference endpoint look like? It's basically a web server with a model hosted there, and your endpoint simply loads the model and then gets the input data from the request, and the response would just contain the output values of the prediction of the model. So now the reason why we're explaining all of this is our goal is to automate as many things as possible with this process. So the question here is it possible to automate most of the processes here? And the good news there is that the answer is yes. Because if you were a data scientist or a machine learning practitioner, it would probably take you maybe days or weeks or maybe even months to complete the entire process. So what's the value of automation? So let's say that we have our model deployed into production. What if we needed to build a new model? Would we need to spend weeks and months again to build a model? Could it be possible for us to automate the process so that if we have new data available, all we need to do is wait for a pipeline to just perform all the steps here and build a new model automatically for us? The other question is it even also possible to deploy the model automatically? So the good news there is that this is all possible now in 2022. Before, you have to build this yourself. But right now, I will share the different solutions available to make this possible in maybe 1 to 2 days or maybe even shorter. If you are familiar with the tools used, maybe in a few hours, you'll be able to build your own ML ops pipeline. So now, let's ask ourselves, can I build an intelligent system in 24 hours? It's not even about a pipeline. It's just an intelligent system. Maybe your system would be able to perform forecasting or prediction. Maybe it would be able to generate images from an existing set of images. So if you were to ask us this question, let's say 8 years ago, the answer to this question would probably be no. If you were to ask us this question this month, the answer to this question would most likely be yes. As long as you have familiarity with the set of tools able to train a model with just a few parameters and then deploy it with a few lines of code. So usually when we talk to engineers and developers and engineers usually prefer to build everything from scratch. However, it is preferred to use a combination of custom solutions, meaning custom scripts, and also we want to make use of existing solutions, platforms, and frameworks. So if you guys have used TensorFlow or PyTorch or MXNet or any sort of library or framework, it's preferable to use those instead of trying to build your own machine learning framework from scratch, because that would probably take months or even years to prepare that. The end goal is to build a model. The end goal is not to build a framework. So creating your own framework is something that you need to consider, especially if you're given a deadline. So yeah, so if you were to ask yourself the question, can I build an intelligent system in 24 hours? Right now, yes, as long as you have the right set of tools. And later on, if we want to build an ML ops pipeline which automates the entire process, if you can do something like that in 24 hours, the answer to that question is also yes. Because there are a lot of options right now when it comes to machine learning automation. So right now, you might be wondering, how are we able to do this? So when doing machine learning, we may be able to do our machine learning stuff in our local machine. However, when we need to deal with production level data sets and big data, we will probably deal with gigabytes of data or maybe even terabytes and so on. And we need to have stronger machines. So when dealing with machine learning requirements, when things are starting to get serious, we will need to have to migrate our experiments to the cloud. So this also allows us to work with other machine learning practitioners and data scientists. So this becomes more or less a machine learning engineering problem where we use custom scripts or maybe custom tools and applications and services with infrastructure. So when you have a smaller data set, when you have a smaller model, then maybe you can use this size of infrastructure. If you have a larger data set and you're going to deal with a larger sized model, then we can easily configure and tweak our scripts to make use of stronger or larger infrastructure, as we can see here in the screen. So one of the best practices when dealing with automated machine learning requirements and machine learning engineering requirements in general is, if you're trying to just make it work, do not try to use the entire data set while you're still connecting the building blocks. Because one of the common mistakes when it comes to development and engineering and integration is we want to have our entire data set, maybe terabytes of data, already being used to train and use it in our ML ops pipeline. But building an ML ops pipeline takes a lot of trial and error. So we just need maybe 5% or maybe 1% of that data to just get the entire process to work. For example, so going back to our machine learning process here, we want to automate all the steps here. So if we were to use a large data set, each of the steps here may take, let's say, 1 hour to complete. But if we were to use a smaller data set, instead of 1 hour, we will be able to reduce that 1 hour processing time to just maybe 5 minutes. So being able to complete the entire process from processing to deployment, we would be able to complete that in maybe 15 minutes or something instead of 3 hours. So you want to reduce the feedback loop whenever we're trying to automate the entire process. So use smaller data set, use a subset, and that's one of the veteran moves I would be able to share with you. All right. Next, let's talk about serverless computing and how it would be used for machine learning requirements. Usually, one of the things I am asked when dealing with these types of topics is people usually ask, if we are to use cloud to host our machine learning models and to host the machine learning inference endpoints, they usually tell me that it's expensive. But if you are very familiar with cloud computing, you should know that given that there are a lot of options, we should be able to select the best option, which is the most cost-effective solution. So what do I mean by that? Let's say that the cost of one server per hour is, let's say, $1. So let's just create some value. So $1 per hour for one server. So if we had 40 hours per week, sorry, how many hours? How many hours per day? 24 hours per day times 30 days, for example. I'm not sure if my computations are correct. Maybe that's going to have a total of 720 hours per month, right? So if it's $1 per hour, then that's going to be $720 per month if we were to host our model inside that server. However, if we have been using cloud platforms now, it's important to note that there are other options available where we can use the serverless counterparts, which would make a lot of sense, especially if the traffic is low or if the traffic is intermittent. Because when you have a machine learning endpoint, a web server there, it is not guaranteed that it will always be 100% utilized. Especially if, let's say, you're just going to host your endpoint for an internal project, there is no point having a server running 24 hours a day, 7 times a week, 7 days a week, right? So if, let's say, there are only 1 to 2 requests per day, so that's 2 seconds only. So let's say the request would take 1 second. So per day, you will only need it for 2 seconds per day. So 2 seconds times 7 times 4 or something, we may be able to just pay $1 or $2 for the entire month as long as we use the right set of infrastructure and tools. So whenever we're trying to deploy something into production, always check if there's a serverless solution to deploy your model. So right now, there are a lot of options possible. So if this is the first time you've heard about serverless, just type in your browser and then you'll see a lot of options available. So in the screen, as you can see here, we can see here that we are going to use a serverless API gateway. And then we're going to use a service called AWS Lambda, where we can install different libraries and frameworks depending on what we need. So if we have a model trained already, we simply upload our model inside this function so that your function would load your model whenever there's a new request, and then your model would be used to perform a prediction or an intelligent decision. So your function would return the response back to the API gateway, and then the API gateway would then return it as a response. So here, if you're just needing this type of setup and there's very minimal traffic, then this may be the setup for you. Yeah, so there are other options. So SageMaker is another option, and it also have there's also a serverless inference option available. In other cloud platforms, if you're using GCP or Azure, there may be solutions like this as well. So as long as you understand the concepts, the things I've shared should also work in other platforms. Whenever we're talking about machine learning automation, we need to take advantage of the cloud infrastructure because there are different solutions available in the cloud which is not available when we're just using our local machine. So here we're going to talk about hyperparameter optimization. When we're talking about hyperparameter optimization, we're just basically trying to figure out what is the best combination of hyperparameter values, meaning configuration values, before training starts. So let's say that A equals 1, B equals 2, C equals 3. Then you produce a model with this performance score. So the next training job would have A equals 7, B equals 2, C equals 7. You start the model training step, and then you produce another model. So what we're trying to do here is we're trying to guess the best combination of configuration parameters so that when we run multiple training jobs and those training jobs produce a model, we want to select the best model available from those training jobs. So if we had 100 training jobs running, then we would have 100 models. And each of those 100 models would have a score, a performance score, a score which would determine which model is better than the rest. So what you do is you select the best model from those options. So now that I have explained what automatic hyperparameter tuning is, how can we use the cloud to take advantage of this strategy or solution? So when you're going to do it in your local machine would be the bottleneck. What if we had 100 machines available all at the same time? So instead of us waiting for all of these training jobs to complete one training job at a time, we can run all of the training jobs all at the same time. So for example, if a training job would complete in 1 hour, meaning your model would be produced from the data in 1 hour, if we were to run 100 of this, then it would take us 100 hours in our local machine to complete everything. Because your local machine is the bottleneck, right? It can only run one training job at a time. What if we run 100 training jobs all at the same time in different computers, in different servers? So instead of us waiting for 100 hours only to find out that there's an error, we can run our training job all at the same time, 100 of them. So it will complete in maybe 1 hour and 10 minutes because the last 10 minutes would be used to compare the different models. So that's one of the things you can use to optimize your work, because in addition to the infrastructure cost, you have to worry about the salaries of the people who are working on this project. So if you have a machine learning or data science team, one of the costs that you need to take care of would be the operational cost. You have to take care of the salaries also. So the longer they wait for something to be completed, that's the overall cost for this project, right? So you need to take care of that whenever we're thinking about cost. And the reason why we're talking about this is a lot of people migrate their projects and experiments to the cloud without taking advantage of what it offers. So if you're asking me, if we were to open and run those machine learning training jobs inside servers, would they need to pay for the servers 24/7? If you use the right set of tools, we would be able to utilize servers which only exist when the training job is running. So once the training job completes, then the servers would automatically get deleted. So we will no longer have to pay for something which is no longer existing. So let's say that the cost of the server is $1 per hour, for example. If we only run it for 15 minutes, then we only pay for 25 cents. So there's no need to worry about a server which is not running because it just gets created while the training job is running. And then it gets deleted after the training job completes. Because your model is represented by model artifacts. And the model artifacts would be stored in a low-cost storage solution. So that's how we do it in the cloud. So everything makes sense so far. So now, the next step is to talk about the different options when working on machine learning requirements. So at the left, you can see that we can build everything from scratch. Maybe we can create our own TensorFlow framework. Maybe we can build our own MXNet framework and PyTorch framework by ourselves. 8 to 10 years ago, this could have been the case. However, if you want to be very practical about it, it's better to use a framework, especially if you're dealing with a team. It's sometimes more effective to use a platform so that a lot of the different members can just use a platform which is already existing and you won't need to worry about building new things on top of an existing framework, because other machine learning practitioners would have probably experienced a problem years ago, and that problem has been solved already by the existing set of tools and frameworks. So instead of you spending 1 week to build something, maybe this something has already been automated by these frameworks. So that said, in addition to this, it's important that we read what the capabilities and things that are possible using those platforms and frameworks, because if we have a new requirement, for example, we want to compute for the class imbalance scores, the PPL, treatment equality scores, and so on, instead of us trying to study all the formulas ourselves, maybe there's already a library or framework which can help us compute this and check for the fairness metrics. Because before you're able to deploy this into production, you have to also check the legal stuff. You have to check if your model is going to be fair and so on. Because this is not just about having the best model. You also have to check if your model is being fair or not. So the topic is not about fairness, but it's important for us to know that this topic has already been handled and being solved already by the different frameworks available. At the same time, you should know the different options available, because sometimes there are already built-in algorithms with a given framework or platform. Or if you have a new model, you can just bring your own container image or maybe bring your own algorithm. So know which options are available, because once you are able to select one of these three options, you can now start with building your own pipeline. At the same time, we want to reduce the amount of effort and code when trying to automate a lot of things. So when you're doing automation, it's better and easier to maintain a smaller code base compared to a larger code base. Because when you're working with data scientists and machine learning engineers, there is no guarantee that your data scientist started with a developer career. Developers are very familiar with development work and coding work. However, some data scientists start first with analyst roles, where maybe if they were promoted or if they had to be a data scientist for a specific project, sometimes it's their first time coding. So the less code that they are managing, the better. That said, it's important for us to look for software development kits which allow us to do a lot of work in just a few lines of code. For example, the automatic model tuning example I shared earlier, instead of us trying to build a system which performs that work for us, maybe we can just make use of a service or a framework where, for example, here in the screen, we just write in 6 lines of code. This is actually just 6 lines. I just indented things and pressed enter. We are able to run a hyperparameter tuning job, which makes use of multiple servers. So let's try to read what's written in the code here. For example, here we specify the hyperparameter range. This is basically the range of the possible configuration parameters. And what we're trying to do here is we're trying to create how many? 20 models using 20 jobs. And we're going to run 3 jobs in parallel. So here, what we want to do here is we just provide the parameters, the configuration settings, and then this code would automatically call and provision 20 servers, and those 20 servers would run one training job each, and each training job would build a model for us from the existing dataset. And the best model would be selected, and that model would be the final output. So this is pretty cool, because if you were to do this 5 years to 8 years ago, it would probably take you 2 to 3 weeks to build something like this. Right now, just look for the solutions available already, and you can do something like this in 1 hour. So again, I'm just using SageMaker as an example. There's most likely a counterpart for this in Google Cloud Platform or Azure or some other cloud platform that you're using. All right, let's now focus on this slide. So we can see here that we have three bars. The first bar is custom implementation. The second bar is configuration. The third bar is ML service. You have an option to use or not use an ML service. So if you were to use an ML service, you have to study the different features and capabilities of that service. So that service may already provide a lot of automation work for you, so that all you need to do is add the configuration code and maybe add custom scripts. If you did not use an ML service, let's say you have a server, a blank server, and you were to write your own custom set of scripts, of course, you have to manage the scaling part, you have to manage the different configuration parameters there. So that would be okay as long as you have DevOps experience or you have the developer or engineering experience. So if you're a data scientist, maybe the ML service option would do the trick for you. But if you have someone to help you do your own custom thing, then that's possible also. What I want to share here is that the custom implementation work, of course, increases if we are not to use an ML service. So it's up to you which option would be best fit for you. Because if you're more comfortable using your own solution, then of course don't use the ML service. Just rely on your own custom tools. At the same time, in terms of dealing with ML requirements in the cloud, it's important to note that these are the things you will probably work with. So if you have used a Jupyter notebook before, then yes, there's also something like this in the cloud. And you'll be making use of libraries, frameworks, packages, and dependencies, your custom code, your data set, and the infrastructure. The ones in white, these are the ones you can control. And the ones in black, Jupyter Notebook and ML Service, it's a black box, meaning it's there for you to use, but you cannot configure and tweak it. So the reason why we're sharing this is the moment you transfer your application or set of scripts into the cloud, you have to take care of the security as well. Because if you are to use, let's say, a framework which makes use of a certain package or library which has malicious code in it, especially for open source libraries where it's not really being checked, or if there's a vulnerability, hackers may be able to use that to attack your environment. So whenever you're working with cloud computing requirements and where you're trying to migrate your ML requirements to the cloud, it's important that you take care of the infrastructure you have there. Because again, the infrastructure required for machine learning experiments may be expensive. And you want to protect these resources as much as possible. So that said, now that we have prepared all of the things that we need and we have discussed all the different concepts, let's now look at how machine learning automation works in the cloud. So this ML service, this is something that I have discussed earlier. And what you want to focus on when dealing with machine learning automation and machine learning engineering work is to focus on the inputs and the outputs. So here, when we're talking about a training job, the inputs would be a data set. The data set which would be used to train the model. We would also deal with custom code so that if we want to use a specific library, let's say Hugging Face library, to perform training, then yes, if your platform or your framework or your service does not support it, then maybe we can use our own custom code. In other cases, we are given the option to provide a custom environment through a custom Docker container image. At the same time, we also need to input custom configuration. And then finally, we have the model artifacts as the output here in the screen. So whenever we're talking about automation, the output of one step is the input for another step. So what will we do with the model artifacts? We have to deploy it, right? So after training the model, you have to deploy it somewhere. And depending on your cloud platform, there are different options available. Do not limit yourself to one deployment option. It's important that you research what is the cheapest option available, what would make sense for your team, and so on. And again, this is just one example and one view if you were to deploy something on AWS. Of course, the logos and icons here would change if you were to deploy the model in Google Cloud Platform or Azure. It is also possible for us to train our model in, let's say, Google Cloud Platform and deploy our model in Azure and vice versa. So it really depends on what works for you. What is important is that you divide the plans for training and deployment. So earlier, we had the model artifacts as the output from the training step, right? So now, we will use the model artifacts as input to deployment. So similar to the previous slide, we can include custom code. So for example, our custom code would be Python code, which loads the model from the file system. And then whenever there's a request, maybe we can use the Flask framework or library to have a web server. So the web server would load the model, and then when there's a request, the request would serve as the input. The input payload would be extracted, and then your model would be used to perform that intelligent decision or prediction, and then the output would be returned back to the user. So this Flask API would then serve as the inference endpoint. If you were to use an ML service, for example, SageMaker, instead of us building that Flask custom app where we have to worry about security, we have to worry about scaling and so on, using an ML service would just allow us to input the 4 input parameters here at the top, and then you can have an inference endpoint automatically served for you. So the good thing here is that if you need a proof of concept work and you want this idea to be approved first, then you can build something like this in maybe 1 hour or 2 hours, instead of you spending 2 weeks to prepare your proof of concept work only for it to get rejected. So if you have a new client and you want to deploy your model really fast, this is one of the ways to do it. It will probably take you 4 or 5 lines of code, and then you can deploy a model already in a staging or production environment. And then after the demo, you can just delete the resources. Wow, that was a lot of things discussed in the last couple of minutes. So now, let's talk about the actual topic, which is automation, meaning complete automation. Because what we talked about earlier is automation on a specific step level. Just training, just deployment, maybe even automated data processing. So now that we can automate all those different steps, is it possible for us to connect these smaller steps into the complete pipeline? And the answer to that question is yes. So here we can see that at the top, we have the starting point. Maybe we have new data. So raw data, and then this step, the first rectangle, that would be the data processing step, where we clean the data automatically, and then we create new columns. So what we can do here is, again, we can have it follow the pipeline, and then at the bottom, we can have your deployed model as a result. So again, this pipeline would have the entire flow completed from data processing, data cleaning, data preparation, feature engineering, up to model training and deployment. And you have the ability to add the if-else conditions and so on. For example, let's say that this is your first time deploying the model. If there is no endpoint yet, then your pipeline would create and provision an inference endpoint from scratch. The second time that the inference endpoint would be used or the pipeline would be executed, since the pipeline already detects that there's an inference endpoint existing, from the first run, then instead of creating a new endpoint, the pipeline would just reuse the existing endpoint and replace the model deployed there with the new fresh model. So if you have been building websites and systems in the past, you should probably know that there's something called zero downtime deployment. So if this model inference endpoint is live, you do not want it to have a 2-hour downtime. You want zero downtime, meaning there's just a quick switch and your clients and customers have no idea that a deployment actually occurred. because there's no downtime, there's no impact to customer experience. So you want your pipeline to do something like that. So we do that with a variety of solutions. So I will not share all possible solutions, but I will let you know some examples, especially for the AWS cloud environment. So this solution, the first one that I'm going to share here, is a combination of SageMaker, which is a machine learning service, and step functions. So if you have used AWS Lambda before, step functions is an orchestration service which makes use of code or maybe UI to automatically create an ML ops pipeline for us. So what we can see here is a very simple ML ops pipeline where we start with data, then there's a training step, and then after maybe 2 or 3 minutes of training, we have your model registered somewhere, and then we deploy that model into its own web server through the two steps here. Because of course, before you deploy your model into a server, you have to prepare the endpoint configuration first, which can be reused later on. And then the pipeline completes. So the advantage of building pipelines with multiple steps is that if there's an issue with one of the steps, this would turn red. And it's easy to know where the error happened. So this allows your ML practitioners to focus on some other projects first. And then if there's an error, you can see it in a dashboard. That's the advantage of having a UI when you're dealing with automation requirements. You do not want your automation work to be just one block of box, and then if there's an error, you have no idea where to start. So be very picky whenever you're choosing tools, because you need to have some sort of way to troubleshoot things, and that is through the logs or through a UI like this. A second solution that I would recommend is to use something like SageMaker pipelines. So a few years ago, before SageMaker pipelines was made available, this is one of the commonly used combination of tools to build MLOps pipelines: SageMaker and step functions. If you want less code, and if you want something which easily works well with SageMaker, SageMaker now has something called SageMaker pipelines, where you can just add maybe 4 or 5 lines of additional code, and you'll be able to prepare and convert your existing code into a pipeline already. So that's pretty cool, because if you were a data scientist, you would probably start first with sample code, which I showed earlier, something like the automatic model tuning code. So 6 to 7 lines of code. If you were to convert that into a pipeline, instead of you building that pipeline yourself with custom software, custom Python code, etc., you would probably just add 7 to 10 lines of code on top of the seven, and then you will be able to have a complete pipeline already. Because that's the goal of the SageMaker Python SDK, to convert the code of data scientists into something which machine learning engineers could already use. So that's pretty cool because it was designed well. So now that we're able to talk about machine learning ops pipeline, it's now time we talk about AutoML. So if we had that engineering capability and the development capability, maybe we can build all of that. And for some of us, we would also be asking, but hey, I have no development experience. This is my first time dealing with machine learning. Where do I start? I have no coding experience at all. Or maybe I have a friend who only knows how to use a user interface. The good news there is that it's also possible for us to do automatic machine learning without writing a single line of code. So there are a lot of no-code AutoML solutions, and all you need to do is type in the browser and search no-code AutoML. So for example, in the AWS ecosystem, there's something called SageMaker Canvas, and all you need to do is upload your data, and then maybe select a target column, and then a model would automatically be generated for you. So there's AutoML there. So if you do not want to use the cloud, there are also AutoML libraries available in Python, for example, where all you need to do is install that library, write in 3 or 4 lines of code, and your AutoML library would automatically run different types of training jobs in your local machine. And then you would have different models, and then the best model would be selected for you. So AutoML is a combination of automatic model tuning, it's a combination of automatic data processing, and so on. So again, this is something which is easily learnable right now. So if this is the first time you're hearing about this, then this is just a Google search away. So let's now talk about the best practices when it comes to automatic machine learning and machine learning engineering. Even if everything is automatable, it is still better if there's a manual approval step. Because, for example, if there's something wrong with your automation code, there's no way for you to prevent or check it if there's no manual approval step. So if you have an MLOps pipeline, or if you have a CI/CD pipeline, you should still put a manual approval step there so that a human can check the final output. So again, this is up to you. However, from what I've experienced, this will always save you if there's something wrong with the final output. At the same time, when you're trying to deal with automation requirements, it's important that you are aware also of the concept of infrastructure as code. So what do we mean by infrastructure as code? When you're dealing with cloud resources and distributed computing in general, you would be creating a lot of resources and trying to make the environment similar for development, staging, and production. It's a bit tricky because a lot of those things would be done manually. However, it is recommended that you convert your infrastructure into a template in code format. So for example, let's say that you have a server in an EC2 instance. Instead of you manually clicking and using your mouse to create a new resource, maybe you can just type in the code, convert that into code, so that it will be used as reference to build environments later on automatically. So let's say that creating a staging environment with 10 resources would take 5 hours to build manually. If you were to automate it and write it in a template, if this template has been consumed by a service, something like CloudFormation, instead of trying to build it for 5 hours to 10 hours, only to make manual mistakes, an automated solution would not make mistakes, and it will be able to complete all the steps maybe in 15 minutes. And if you need to delete the resources right away, yeah, you can delete it because there's no danger. Because all of the resources configuration is stored in that template file. And if you want your databases to be retained after all the other resources have been deleted, that's possible as well. Because there's of course the termination configuration. So if you do not want to delete the databases after creation, then you can have that retained as mentioned. And if you need a lot of environments, then from this template, you can prepare your production environment. You can create an environment for your manual penetration testers. You can create an environment for the load testers and so on. If you're done using all of them, you can delete it right away. So yeah, so we talked about a lot of best practices and techniques as well as different concepts. And yeah, that's basically a good overview and summary of how machine learning engineering can be automated in the cloud. And if you're interested to know more about machine learning engineering and automation, I'm actually writing a second book after the first book, which talks about this. So the title of the book is Machine Learning Engineering on AWS, and it will be published maybe Q4 this year. So again, keep that as a secret for now because it's not yet in Amazon. But maybe in 2 months or 3 months, once the book cover has been prepared by the publishing team, it will be there in Amazon later on. So thank you again. Hope you learned something new and opening the floor for questions. Yeah, don't be shy. Yeah.
I see we don't have any questions. Yeah, maybe because your topic was very clear and understandable for our viewers.
Oh, there's actually a question here. If we are a small startup, when it will be a good time to start to use AWS for deep learning? Right? Really good and valid question. If you are a startup, if there's someone in your team already familiar with AWS, for example, a developer, then yes, it's a safe time to use AWS for deep learning as long as your developer has a good idea on how costs work. Because when you're using AWS, you can get a lot of things for free if you know how to use it. Similar to what I shared earlier about serverless. If nobody is using your application since it's still in staging or there's still no customers yet, you can utilize serverless technologies in AWS to significantly reduce your cost to maybe $1 per month or maybe even free. A lot of companies do that. And sometimes there's also free AWS credits for startups. So look for those companies which offer free AWS credits for startups. I believe that they give you free money, free credits, especially for startups. And then for your data scientists and machine learning practitioners, if you are to use deep learning for your machine learning requirements, it's better that your machine learning practitioners are first familiar with the frameworks that you're going to use. So for example, PyTorch, MXNet, or TensorFlow, if those machine learning practitioners and data scientists are already comfortable using it in their local machine, then it's easy to use it in AWS. You usually use AWS for production requirements or staging requirements like test environments. But if you can get it working in your local machine, then that may be your first step. And once you need to do a demo or have it integrated with a real environment, then it's time to use your cloud environment. So it can be AWS, it can be GCP or Azure. The concepts that I've shared is relevant to all platforms. Yeah, but yeah, good question. Thank you too. Yeah.
So I think this is all. And I'm grateful to Joshua for the great webinar. The topics was very interesting. Thank you.
Thank you.
So, bye-bye.
Have a great day ahead. Bye-bye.
Bye.
Bye. Bye.